Madam Kong. Today we are going to learn about mole concept. Actually, the mole concept you have learned before during secondary school, Form 4, Chapter 3. But never mind, let's do some revision. So this is the diagram showing the conversion of mole between molar mass, molar volume, and number of particles. So you always apply this kind of formula during secondary school. If you want to find mole, you must divide it by molar mass, divided by number of Avogadro, and divided by the molar volume. Either is STP or room temperature. So this concept is still correct. But now you're up level, you have to find the relationship among the mole versus molar mass, mole versus molar volume, and mole versus number of particles. No worry, just follow. Let's check the understanding about 1 mole. We must always remember 1 mole actually is the amount of substance contain equal number of particles, either is in atom, molecule, or ion, as in 12 grams of carbon-12. So for 1 mole of carbon-12, it has a mass for 12.0 grams. So this one is molar mass. At the same time, contains 6.02 times 10 to the power of 23 atom. So this is number of particles. So this number of particles, right, there is a name for it. We call it as Avogadro's constant, or the symbol is Na. At the same time, 1 mole of gas, right, is equal to 22.4 liter at STP and 24 liter at room temperature. This is molar volume. This one is refer 1. So we look at 2 examples. If 1 mole of sulfur, right, if you go to check the molar mass, is equal to 32 grams. At the same time, it also equal to 6.02 times 10 to the power of 23 sulfur atom. Okay, if 1 mole potassium chloride is equal to 74.6 grams. So this one you can check the molar mass of the relative atomic mass of potassium and chlorine, you get this value. So it's also equal to 6.02 times 10 to the power of 23 potassium chloride molecule. Okay, and 1 atom, so 1 times 6.02 times 10 to the power of 23 for potassium atom and for chlorine atom as well. Okay, now we go to molar mass. Molar mass is refer the mass of 1 mole of an element or compound in gram per mole. So what is relative molar mass or relative atomic mass? Actually, the value is the same, just cancel off the unit. Why? Because already compared with carbon-12. Okay, now how to find a number of mole? If for a compound like solid, we're using mass over molar mass. For liquid, normally we are using mV per thousand. The V is in mole, that's why I need to divide by 1000. If the volume already in liter, you no need divide by 1000. Okay, for gas there are 2. Okay, one is STP, another one is room temperature. So we are using the volume over the molar volume, depends the condition. If STP, this one. If room temperature, this one. Okay, so you have to know STP. What is the condition of STP? STP is standard temperature and pressure. So the temperature is refer 0 degrees Celsius or 273.15 Kelvin. And then the pressure is 1 atm. Okay, for room temperature, okay, the temperature is 25 degrees Celsius or 298.15 Kelvin. Always remember the relationship between liter, dm3, and cm3. 1 liter equal to 1000 ml. Okay, 1 liter also equal to 1000 cm3. Okay, let's look at the example question 1. A gas X occupies 345.1 cm3 at STP. Calculate the number of gas molecule in the sample of X. Meaning that we need to find the number of gas molecule. Okay, from volume, if you want to find the number of gas molecule, we need to get the number of mole first. So we must compare this volume with molar volume. STP means 22.4 dm3. Then only can proceed for second step to find the number of gas molecule. So step 1. Okay, so the relationship is 22.4 dm3 equivalent to 1 mole of gas X. In this case, this one is in cm3. That's why we might convert become dm3 first. That's why divided by 1000. And then so 0.3451 dm3 times 1 mole of gas X divided by 22.4 dm cube. Unit cancel, so remain mole gas X. So the answer is 1.5404 times 10 to the power of negative 2 mole gas X. Since this one not the final answer yet, make sure your answer in 4 decimal places. Okay, after satisfy the number of mole, okay, now we proceed for molecule, number of molecule. So every substance in 1 mole gas or 1 mole solid or 1 mole anything equal to this one, 6.02 times 10 to the power of 23 molecule. Okay, now the mole that you success get from the part 1, so you just cross this one times this divided by this. So this times this one, okay, divided by 1 mole cancel. So the answer is 9.27 times 10 to the power of 21. Don't forget the unit, molecule. Let's check question 2. So there are a few questions that related with mole concept, involve molar mass, molar volume, and number of particles. Let's go through one. So question number 2A. So calculate the molar mass. The question asks about molar mass. Mass means gram of a compound if 0.372 mole of it has a mass like this. So meaning that the first general relationship is 0.372 mole equivalent to 152 gram. Okay, and then this question 1 molar mass. Molar mass is referred to 1 mole. That's why 1 mole stoichiometry 1 times 152 over 0.372. Mole cancel off, so you get this answer. Don't forget to make a conclusion. Molar mass of compound equal to 408.60 gram per mole. Now let's look at question 2. How many molecules of ethane are present in 0.334 gram of ethane? So first of all, we must understand the question. Need to find molecule of ethane, but the number of mole is not given. The mass is given, meaning that we need to find the mole of ethane in 0.334 gram first. Okay, if we want to apply the stoichiometry method, we must know 1 mole of ethane equal to how many grams. So this one we need to find the molar mass of ethane. The molar mass of ethane equal to 12 times 2 plus 6 equal to 30 gram. 1 mole of ethane equal to 30 gram. At the same time, 1 mole of ethane equal to 6.02 times 10 to the power of 23 molecule. So this is the relationship between mass and number of molecule. So now the question asks about 0.334 gram equivalent to how many molecule of ethane. So cross multiply divided by 30. So this 0.334 times number of Avogadro divided by 30 gram. Gram cancel, so the answer is 6.7 times 10 to the power of 21 molecule of ethane. Remember, must take the unit. Okay, next look at question C. Question C asks about calculate the number of carbon, hydrogen, and oxygen atoms. There are 3 questions. In 1.5 gram of glucose, C6H12O6. Actually, this question is exactly same as question 2B. Okay, first we need to find out the molar mass, number of mole of glucose. So based on here, right, we know that at 100 gram of glucose equivalent to 1 mole of glucose. So now the question asks about 1.5 mole. So 1.5 times 1 divided by 180 grams, so you get 8.3333 times 10 to the power of negative 3 mole. Okay, so this is a step 1. After you satisfy the number of mole, you must know 1 mole of glucose equivalent to 6.02 times 10 to the power of 23 molecule of glucose. So in this case, 1.5 gram equivalent to this number of mole, 8 point something. So now the question asks about carbon. Okay, so for carbon, before we proceed for carbon, we must know what is the number of molecule of glucose first. So again, using stoichiometry, this times this divided by this, and then you get 5.01 67 times 10 to the power of 21 molecule of glucose. So this is the number of molecule of glucose. But the question asks about what? Atom for carbon, hydrogen, and oxygen. So you check, there are how many atoms of carbon in glucose? Answer is 6. That's why I need to times 6 for this number of molecule. How about hydrogen? Hydrogen 12. That's why you need to 12 times this number of molecule. So in order to get the atom of hydrogen. Same for oxygen. Oxygen you need to times 6. So you get this number of atom for oxygen. So 1, 2, 3. 3 of these are the final answer. So for this kind of question, you must be clear what the question asks about. You have to solve it step by step. First is you must find the mole of glucose based on 1.5 gram first. After that, you must find the number of molecule based on this number of mole. Then only you can find the number of atoms for each of the element. This for carbon, this for hydrogen, this for oxygen, based on the number of atoms for this molecule for glucose. Clear? Okay, for question 2D, how many atoms are there in 5.1 mole of sulfur and 2.1 gram of copper? So for D1, easier because mole is given. So if we want to find an atom, we just times 6.0 times 10 to the power of 23 atoms. So first we must make the general statement. 1 mole equivalent to this number of atoms. So 5.1, okay, so stoichiometry 5.1 times this divided by this. So mole s cancel, so remain the unit is atom. So the answer is 3.0 times 10 to the power of 23 atom of sulfur. Okay, for D2, from mass to number of atom, so we must find the mole first. So we can directly using the general statement, mass over molar mass, and then you get the number of mole. Or if using the stoichiometry method is, okay, 63.6 gram is equivalent to 1 mole of copper. So 3.14, okay, actually the step over here is the same. But why I keep on insist you all using this method? Because you will know gram cancel off, the remaining unit is mole copper, so no confuse. Okay, based on the mole that you successfully in this part 1, and then you can continue to find the number of particles. So 1 mole is equivalent to 6.02 times 10 to the power of 23 atom. So this number of moles, stoichiometry again, this time Na divided by 1 mole of copper, and then you get the answer 2.97 times 10 to the power of 22 atom of copper. Clear? Okay, for question 2E, the concept is exactly same as 2E. You try to go through by yourself. So mole is from mass, want to find the mole is straight away divided by molar mass, or we can using the stoichiometry method as well. And then from number of atom to find the number of moles, so we just need to divide it by the number of Avogadro. Okay. So find the relationship for 1 mole is like this. So now is the number of particles given by the question. So this times 1 mole divided by number of Avogadro, then you get the answer. Okay, so this is the question inside your lecture notes. So try to read your lecture notes and compare with this video. Then start again, enhance your skill by doing tutorial question. So there's another video, mole concept part 2. It discusses the mole question for tutorial for 2. Please stay tuned. So that's all for today. Don't forget to follow my IG at ChemiComSL. Subscribe, like and share my YouTube channel ChemiComSL, and follow my Facebook ChemiComShirley. Hope you all learned something. Thank you.